We are now going to go into our final session for the conference. And this session is a really exciting one. We're covering bold visions for the future. So we're going to be looking at circularity, natural materials, using less stuff, ethics, and the digital future. So I'm going to get started with our first speaker, Menno Rubens from CPZ Projects, and he's going to present on The Future is Circular. So over to you, Menno.
Thank you very much. Good afternoon, good morning, wherever you are. And on the planet, my name is Menno Rubens. I'm here today on behalf of CPZ Projects. CPZ Projects is a proud member of the development, or is the development branch of the CPZ Group. That's CPZ Group is an ecosystem that brings together design, engineering, and execution under one roof. We work shoulder to shoulder with our sister disciplines, CPZ Architects, Interior, and the Building Management branch. Together, we form one integrated interdisciplinary team. And we like to say from idea to realization and beyond. Because we don't just deliver buildings, we deliver systems that perform, evolve, and endure. But we don't stop there. We actively seek long-term partnerships across the chain, from demolition and material experts to contractors and system integrators. These aren't ad hoc collaborations, they're deliberate structural alliances, crafted to share knowledge, align incentives, and accelerate innovation. And why do we do that? It's because we believe this is the only way to deliver what we truly need today, that's smart, adaptive, and circular buildings. Let me show you what this looks like in practice with some of our projects. We developed the temporary courthouse in Amsterdam, a fully demountable high-grade building. I'll come back to that a little bit later in more detail. We also created the greenhouse in Utrecht. It's a circular energy neutral restaurant designed to be completely disassembled and rebuilt elsewhere. And also we're redeveloping a theater in Os. That's a city in the south of the Netherlands. And we use harvested materials that came from this theater in Scheveningen in The Hague to transform it into a vibrant, multifunctional complex, breathing new life into the existing components. And we deliver modular laboratories and flexible office hubs tailored to every evolving user needs. It's like Lego for grown-ups. In every case, we ask, how can this building serve today without limiting tomorrow? Because we don't just design for use, we design for reuse. And why does this matter? What is the urgency of it? Well, let's talk about the elephant in the room, the CO2 emissions. The construction sector is responsible for nearly 40% of the global CO2 emissions. That includes everything, the extraction of raw materials, production of building components, transporting, logistics, construction activities, everything, and the decades, especially also the decades of operational energy use of the buildings. And that's a staggering figure, and it means that if we are serious about achieving the Paris Climate Agreement, we cannot delay. We must radically rethink how we build, and we must do it right now. Circular construction for us is not a niche. It's not an experiment. It's not a buzzword. It is urgently necessary. It's an urgent necessity, and we're already doing it now. At CPZ, we're driven by two sources of inspiration. The first one is this definition of sustainability by the Brundtland Commission. It's meeting the needs of the present without compromising the ability of future generations to meet their own needs. And this sentence should be engraved in the minds of everyone who shapes the built environment. The second inspiration comes from Stuart Brand, author of the book How Buildings Learn. You see the cover of it on your screen. And he offers a compelling critique of how some buildings are successful while other buildings fail. He has three key ideas that guide our thinking in a large scale. The first one is that all buildings are predictions, and all predictions tend to be wrong. This reminds us to embrace uncertainty and not fight the uncertainty. We can't predict the future as humans, so we must design for the change. And this graph of predicted versus actual installed solar panels shows you just how wrong even experts can be in their forecasts. So let's build structures that are flexible by design, not locked into rigid scenarios. And most buildings, he says, are also prematurely complex, which blocks adaptability. We often should start with a simpler structure that enables complexity to emerge over time. And also, what he says is that buildings are made out of layers, and those layers have different lifespans. So mixing them up is a recipe for waste. Separating them makes change easy. Think of it like a sandwich. If every layer of a sandwich is glued together, you cannot swap the lettuce without throwing the whole thing out. The same applies to facades, to interiors, to surfaces, to structures. Keep them distinct, keep them accessible. And at CPZ Projects, we've translated these insights into a concrete approach. We call it making buildings that are circular ready, a circular ready construction. We don't claim to have all the answers about the future circular economy, but that is exactly why we design our buildings to be ready for it. And the kit of parts thinking that we use is at the heart of this method. Each building is assembled from standardized demountable components. That means they can be taken apart, can be moved, can be reused, can be reconfigured, and can even be completely reimagined and replaced and moved. The benefits are enormous. We can reduce the use of raw materials. We can cut down construction time, and most importantly, with this method, we eliminate waste, because in a circular economy, waste is a design failure. Recycling is merely damage control, and burning material is a desperate last resort. So our goal is to make waste obsolete, and we aim for total reuse, not just in materials, but also in function and in form. Let me take you back to the temporary courthouse that I talked about earlier in Amsterdam. This was not a shipping container or a pop-up shed. It was a fully functional, high-quality building used for 7 years by the judiciary. And from day one, we designed it with the future use in mind. Can it later be an office? Can it be a school? Can it be apartments? All those functions should be possible in our view. The structure that we designed was modular. The services that are integrated are separable, and all the components were cataloged in the BIM model. And when the building was no longer needed on that site, what did we do? Well, we took it down piece by piece with care, with precision. And here's the best part: 90% of the building's CO2 footprint, embodied carbon, was directly reused on the new site. So there's no offset, there's nothing recycled, it's all reused. And here you see the materials on the new location. And today that same building is being reassembled as a hybrid office and an educational center. The same parts, but on a new location and with a new life and without any waste. And this is proof that this approach works. It's scalable, it's repeatable, it's commercial viable, and it's already happening. And let me leave you with a few key messages. The construction sector holds a massive lever in the climate transition, and we are part of the problem, but we can also be a very big part of the solution. At CPZ Projects, we use that lever to build a circular and adaptive future, project by project. And our kit of parts methods turns uncertainty into opportunities. And we work in deep collaboration across the chain to bring this vision to life, together with contractors and demolition companies. And we're showing, not just telling, that a different way of building is not only possible, but it's preferable and it's commercial viable. The future is circular, and if we choose to build it that way. And at CPZ Projects, that's a choice we have already made. Thank you very much for your attention.
Fabulous, thank you so much, Mano. We're going to move on to our next speaker. We have Barbara Jones, the founder of the School of Natural Building. And Barbara's going to present on the future is natural materials. Over to you, Barbara.
Thanks, Brogan. That was very inspiring, Mano. Thank you very much indeed. So I'll go straight into what I want to say. And the global use of cement is a major driver of climate change. I'm sure everybody realises that. And the UK construction industry in particular is a dinosaur preventing change and needs to transform. Grenfell showed us the corruption within our system and the failing of modern materials. Regulations need to be visionary and move on from outdated methods. We already have planet-friendly solutions and they do not require major changes, only commitment. And bio-based materials, especially annually renewable ones like straw and hemp, can and should form the basis of our construction going forward. So this is my premise for today. So to start with the past, we can learn a lot from the past. We don't have to always replicate it, but we can adapt what works. And here we've got a very simple foundation with stone sitting on top of the earth. So no trenches, no need for cement, something that has lasted over 100 years already. We've also got something that at first sight might look like a failure, but actually, because it was made with lime and stone instead of cement and stone, it has lasted the test of time and it has actually become a tourist attraction. So old buildings give us ideas for modern buildings. The ideas can be very simple, but that doesn't mean that there's something wrong with them. They could still work in the 21st century, and they can still work even if the ground conditions have not been fully understood, as in the right-hand case. There are plenty of examples of cement-free designs available. I've specialised in them in my career of 45 years in construction, and a lot of these designs are freely available for you to copy and adapt for your own use. And a great way of combining natural materials with recycled materials is to make cement-free foundations using pillars of car tyres, which can be built very cost effectively. And these have been passed by planners and by building regulations, so they've got full approval in the UK, and that has been in existence since 1996 when the first ones were passed. Another way of building foundations, well, this is the same way, using car tyre foundations. I want you to see that we're talking about real buildings. So this is a 3-bedroom, 2-storey, small straw bale house that was predominantly self-built, but not exclusively. They did have carpentry help to do it. And it's built on car tyre pillars. And you can also see on the right-hand side of the foundation photograph that the retaining walls also don't contain cement. They're made of steel gabions filled with stones. So this building is a natural building. So the walls are made of straw. The outside is rendered with lime and the inside is plastered with clay. On the other side of the scale, thinking about what Mano was talking about, here we have modular panels made in a factory, these ones in Slovakia or Lithuania. A factory will be coming to the UK shortly. And these are eco-cocoon straw panels. They are 400 mil deep and they have a U value of 0.123 when they're fully fitted. They're a passive house certified system. They're extremely simple to put together, so simple, in fact, that lots of self-builders are using them in the UK. And they're also very cost effective, because if they weren't, self-builders wouldn't be doing it. And they're more affordable than other SIP systems that are available, because they only have 4 layers, and because they're made of renewable materials. There is no other system that is as sustainable as straw. 88% of these panels is made of straw, and that can be grown each year without changing any agricultural practice, because in the UK we have 5 million tonnes of straw surplus to requirements every year. We can build everything we want and more with that amount of straw. In Sweden, where they have a different way of understanding fire risk, they have built the Hailey project, which is a 12-storey apartment block using eco-cocon straw panels for the walls, for the external walls, and the structure is held by CLT panels in the middle with a concrete staircase. And you can see from the costs here that it saves an awful lot of money compared to other building types. We're not able to go this high in the UK. We can only go to 18 metres because of the lack of understanding about how these materials work in practice at the moment. Here we've just got a couple of examples of the eco-cocoon straw house finished. Both of these are self-builds. They both meet all the regulations in England and in Scotland and Wales. And the right-hand one also has foundations with no cement in. This is what the foundation is like for those, for the right-hand house. It's actually a foamed glass geocell, chunks of hardcore, if you like, which has different purposes. So it acts as a hardcore, it acts as an insulation, and it acts as a capillary break, which is the old-fashioned way of preventing moisture movement upwards through a building. And it's based on the ideas of road building. So when I first designed a house or a building with this type of foundation, my ordinary engineer wasn't able to do it, and I had to transfer to an engineer who knew about road building. But to be quite honest, the road building ideas also go back to where we were at the beginning of this slideshow, which is they were following ideas that the Romans had put forward for taking roadways across marshes and ground with no good bearing on it. And so a lot of the ideas that I use are adaptations of the past. And you can also see that we used just a big lump of stone to hold down the veranda roof against wind uplift. So very, very low carbon. In fact, this will be a net zero house, if not a negative carbon house. So before 1919, almost every building was cement-free. They were also all made of natural materials. Most had a lifespan of 200 plus years, and as buildings, they were predominantly healthy places to live. Nowadays, almost all buildings are made with cement and concrete. They all contain toxic materials like PAR, insulation, and squirty stuff in tubes. Indoor air is full of pollutants from various different things. We don't need to go back to the past, but we can use their good ideas and build on them to create a healthy future. And just by way of illustration of that, we've got the Sydney Opera House, a beautiful, iconic concrete building with a projected lifespan of 250 years. We've also got the Pantheon in Rome, which is already over 2,000 years old. It's been neglected for huge amounts of time, and it potentially has thousands more years of life left, and it's built with stone and lime. It's something we really need to be thinking about if we're going to go forward. So I'd reiterate what David said at the beginning. Don't be afraid to speak up and offer other material choices and design solutions throughout every building that you're working on. Thank you very much.
Amazing. Thank you so much, Barbara. That was really inspiring and fantastic case studies there. Looking forward to chatting at the Q&A. We've got a few more, so we've got 3 more speakers left. We have our next speaker is Takuma Watari from the National Institute of Environmental Studies, and the presentation is on the future is using less stuff. Over to you.
Thank you for the introduction. Yeah, I'm Takuma from the National Institute for Environmental Studies. I think what I want to do in this presentation is to give you a scientific evidence on why we need to use less materials in construction. So I want to start with this bit of a complex diagram, which shows how materials and energy move through the global economy and turn into greenhouse gas emissions. And this systems will allows us to see which activities are actually driving emissions. So as expected, we see significant emissions from driving vehicles, running buildings, and making foods, which we often talk about in the context of climate change mitigation. But industrial activities to produce materials such as steel and cement produce even more greenhouse gas emissions. So what we can see in this diagram is that industry is the largest source of greenhouse gas emissions at the moment. And if we see where the demand for this material is actually coming from, then we see construction is the biggest driver. So if we are serious about global decarbonization, we can't just focus on promoting electric vehicles, improving building ventilations, or using more renewable electricity. We also have to think about how we can decarbonize the industrial sector, where we produce whole bunch of materials for lots of applications, including construction. And there are lots of ideas out there about how we can decarbonize the industry emissions, but my argument is that recycling won't save us unless, I mean, but the most common ones which we see across sort of policies, medias, or academic platforms tend to focus on 2 things. The first is doing more recycling, and the other is developing more innovative technologies on the production side. And these are important strategies, but my argument is that the recycling won't save us unless the growth of in-use material stock has stabilized, and technological innovation on the production side is highly uncertain given the history of over-promising and under-delivering. So the logical conclusion to me is we need to use less materials in construction. So that's my sort of argument in this presentation. So let me walk you through each of these points. So what we see in this diagram is like the current global concrete flows. So from the left, we have the iron ore extraction, which then moves through the stages of iron making, steel making, forming, fabrication, in-use stock, and waste management and recycling. So at the moment, the global steel industry requires about 1,800 megatons of iron input for steel making, and about 600 megatons of that comes from recycling. So this means the global recycled content in the steel making stage is about 33%. So despite the steel's sort of inherent recyclability, so steel is magnetic, it's relatively easy to separate from waste stream, and also the decades of industry's efforts. Only 1/3 of the iron inputs currently come from recycling. And the important point here is that the limited recycled content is not because of the poor waste management. In fact, what we can see on the right side of the figure is that more than 80% of end-of-life scrap is currently collected and recycled. But the real challenge is the growing in-use steel stock, which is still embodied in products, buildings, and infrastructure. So what we see on the right side of the figure is that steel inflow into the use phase is about 3 times higher than the outflow, which means even with perfect recycling, without any process losses, recycling alone could only meet part of the demand globally. And this sort of imbalance between inflows and outflow is not a short-term phenomena, but actually as part of a long-term trend. So what we say in this diagram is that over the past 2 decades, the global steel industry has made significant efforts to recycle more and more scrap, and end-of-life recycling rate has improved from about 60% to more than 80%. But at the same time, the EU steel stock has continued to expand, which means scrap availability relative to demand has been declining over the past 2 decades from the year 2000 until 2020, as you can see here. And the consequence of this stock expansion is the stagnation of recycled content in the steelmaking stages. So what we see in this diagram is that the global recycled content in the steelmaking stage has been stagnated at about 30% over the past 2 decades. So in that sense, the industry hasn't been able to close the loop because the EU steel stock has been growing much, much faster than the improvement in the waste management stage or recycling efficiency. And of course, recycling status varies across countries. But if we are looking at what kind of factors explain regional differences in recycled content, we found several important points listed here. So the domestic scrap availability explains recycled content in some countries, but it's not a determining factor in most cases. Instead, recycled content is largely shaped by international trade. So the recycled content across countries is not determined by how well these countries recycle within domestic borders, but rather determined by how these countries interact with an international market. And so seemingly high recycled content in some places is often supported by low recycled content elsewhere through scrap imports or offshoring the production of high quality flat products. So eventually our data, or like we conclude in the study that as long as global EU steel stock continue to grow, more recycling in some places do not necessarily lead to global progress. So clearly, recycling won't save us unless we stabilize the growth of in-use material stock. So that should be the priority. So that's my first argument. Now I want to move on to the second part of my argument, because many are placing their hopes on technological innovation on the production side, such as carbon capture and storage or hydrogen. But the key question is whether these technologies can scale up fast enough. And unfortunately, our study indicates this is highly uncertain or highly unlikely. So let's look at the cement as an example. So what we see on the left side of the figure is that the CO2 emissions from the cement production has tripled between 1990 and 2020. And during this time period, industry made significant efforts to actually reduce the CO2 emissions by 20% per unit of production globally, through such as clinker substitution, energy efficiency improvements, or using low carbon alternative fuels. But increased production has outweighed these gains, as you can see here. So the demand for these materials are growing much, much faster than the improvement in the technological improvement on the supply side or production side. And this is the pattern we can see across many industry sectors. So in this context, more sort of innovative technologies such as carbon capture and storage has long been seen as a key solution, but we have a track record of over-promising and under-delivering. So if you look at the 2010 IEA report, so International Energy Agency assumes that the CO2 capture and storage for the steel and cement sector would reach roughly 200 megatons of CO2 by 2021. But because our progress was too slow, they have adjusted their projections over time. And so we have a clear downward trend on the left side of the figure. And today we have almost negligible amount of carbon capture and storage happening in these sectors. And yet, if we look at the 2050 projections, then we see International Agency almost constantly assumes about 2,000 megatons of CO2 will be captured in these sectors. And that would be a remarkable achievement if we could get there within the 25 years. But given the scale of challenges and also our history of failure, the actual deployment is quite uncertain, if not highly unlikely. So based on all these data, we estimated how much materials we could possibly produce within the finite global carbon budget. So I won't go into all the details, but the key takeaway is that the feasible supply of steel and cement within a carbon budget is likely to fall short of expected global demand. So we have the feasible supply here and the expected demand here. So we have a clear gap in supply and demand. So clearly we need to use less steel and cement in construction, which is the largest user of these materials. So to summarize, recycling won't save us unless we stabilize the growth of in-use material stock, and technological innovation on the production side is highly uncertain given the history of overpromising and underdelivering. So the logical conclusion to me is we need to use less materials in construction. I think many of you in this room have far more expertise than I do in this space, but I think like what I can offer from sort of systems science or systems analysis perspective is that the benchmark we need to achieve is something like reducing the use of steel and cement in construction by at least 25% by 2030 and by 50% by 2040. So these are the minimum requirements that we as a citizen in the global north must achieve in order to stay within the fair share of the global carbon budget based on our study. Yeah, so that's it. Thank you for the attention.
Amazing. Thank you very much. Getting on to our next speaker now, we've got Paula McMahon from Sir Robert McAlpine, who is going to be presenting on The Future is Ethical. Very excited for this one.
Thank you very much, Brogan. Can you see that yet?
Yep, all good.
Perfect, yeah. So you'll see on the advertising, I work for Sir Robert McAlpine, but I'm also the Institution of Civil Engineers Trustee for Professional Conduct and Ethics. So today's talk is going to be about the future is ethical, but it's going to be more general, not to do with my design background or my construction hat on. It's more to do with ethics in general, and it's very much about you. So I want you to think, how often do you think of all of the stuff? You probably think of engineering quite often, but how much do you actually think of integrity and the whole planet? Basically, how much do you think about how you impact upon our future? Now, I put this slide in because this is a question that I was asked by university students, because for those that don't know, the JBM require the university to consider ethics. So they consider ethics during their studies, but how much do you think about it whilst you're practicing? The answer to this question was, for me, when I was asked how often do I think about it, my answer was too often. So what is ethics? Let's baseline what it actually is. Well, I think of ethics being in the grey. It's the things that we don't know. We very much have the law, which is what we must do. We have rules and guidance, which is what we should do or could do. And we have our cultures, which vary place to place, geographically, company-wise, sector, and that's what's expected of us. For those that sort of want a definition of ethics, you'll find many, many definitions, but the Institution of Civil Engineers in the Code of Conduct describes it as doing the right thing. So if you think about ethics as doing the right thing, that's what we're aiming towards. But obviously in itself, that's quite a vague description. But what I want us all to do is to move together from the grey, from that unknowns, thinking of it to the green. So we've already talked about various things today. Our speakers have mentioned Grenfell, Barbara mentioned Grenfell, and that's obviously made us think about things to do with building safety in a particular way, and also the cultures that we're involved in. So let's have a think about some things we can start today and actually do to make the future ethical. Well, I'm going to give you my bold future to do with culture. So in that future, when the future is ethical, we are going to collectively, that's together, us all, in a global context, that's not in any individual place or any individual company, but we're all going to just be expected to do the right thing. Now, I've put various 2D representations of the planet on the slide there, because what I want you to do is think about that global nature of it. The globe is our globe, and it's not just your side of it that you're thinking about. So let's start thinking about the consequences of what we actually do truly globally. It's not just what's going to happen in your backyard, what's going to happen on the other side of the planet. And what's also going to be a thing of the past in my bold vision of the future is that we're not going to think about doing the profitable thing. We're not going to think about that cost in terms of money. We're going to think about the value in terms of the thing that we provide that's going to be good for our client, but also the value that we give to the planet, or the value rather that we don't take away from the planet, the consequence that we've got. So what can you do today? Well, you can start thinking in them terms right now. You don't have to at all wait until tomorrow until everything's perfect. You can start thinking of them today. So let me give you some more food for thought. So we know that laws change things. And I mean, Barbara's enlightened me today about the foundations. I did not know that it was within our rules today that we could actually use tyres for foundations. And, you know, but the same journey that we went through for health and safety is a similar journey that we're going through now for the climate. And years ago, and it's certainly in the UK, safety had a cost. There was a monetary amount. There was an amount at which you said, you know what, we don't have to pay this out. And we know that people were less safe. And now that really isn't the case. I mean, think to yourself offline, how much money would you think is acceptable to knowingly do harm to someone when it comes to a safety aspect? And if you really think about it and really honest with yourself, I think you might learn something about how your mind works and how you can become more ethical. So let's face it, it isn't that easy in terms of the climate. It's a much bigger and more complicated issue. We've got that offset, that balance between using less stuff that we've definitely got a very good case for, but use less stuff. Arguably, a structure on one hand could be less resilient to climate change. It does have less carbon, but then is it going to be more subject to failure in the result of a storm, a flood, and other things that we're inevitably going to get as a result of climate change? However, you are today's, yesterday's, or tomorrow's engineers and technicians in the structural field of engineering. And if you can't solve the problem, then quite frankly, who can? You look at the risks all the time. You look at the balance of various things. So you're doing this balancing act all the time. So all I'm asking you is to consider carbon, the use less, the use the natural materials, and to think of the circularity a little bit more than tomorrow than you did yesterday. So my other specific ask is something that you can do again today or tomorrow. You can actually start using your guidance the same as if it was law. Why wouldn't you? So two specific things that come to mind are, one is Part Z of the building regulations and the other is PAS 2080. Now they both lend themselves to the UK. However, both of them can actually be used globally. And even if everything in them can't be used, consider the concept that can be used. So what I would like you to do is think a little bit more in terms of integrity and ethics, so you can change what you do. If you use guidance as if it was law and use the best practice of everybody, then I think we'd all be in a much better place to be towards our global vision of being ethical. And ask yourself what's stopping you from starting that progress today. Thank you.
Amazing. Thank you so much, Paula. And there's a lot to think about and reflect on there. So thank you for that bold provocation. And we are moving on to our final speaker of this session. We've got Caitlin T. Mueller from the Massachusetts Institute of Technology presenting on The Future is Digital. So over to you, Caitlin.
Thank you so much. It's such an honor to be here, and it's been a really inspiring and very early morning for me here in the United States. I want to start by talking about embodied carbon, the reason that we're all here. This is a study that some of my colleagues did 10 years ago, looking at the embodied carbon per seat in Olympic stadia. And I'm still shocked by this finding that was part of a larger study. They found that The London Olympic Stadium from 2012 uses just 1/14 of the embodied carbon from the Beijing Olympic Stadium for 4 years earlier, normalized by seats. They're both made by the same material. They're both made out of steel. So it's not just a question of material substitution here. Why is the embodied carbon so different? It really comes down to design. And as we've collected more data about embodied carbon from practice around the world, this is recent data from the United States from the Carbon Leadership Forum, we continue to see this remarkable spread in embodied carbon. Here we're looking at several hundred buildings normalized by square meter across 3 different material systems. Again, we see a huge differential here of more than 8x. And it can't be explained by material alone. Again, my argument is this comes down to a question of design. We know this conceptually. The best structures from around the world and from throughout history use design explicitly to achieve remarkable forms, but also remarkable efficiency, lightweightness, use of material that is intelligent and driven by design. These structures are remarkable, but unfortunately, they're also fairly rare. We need to think more about how high performance design, which has so many benefits, can play a role not only in the construction of remarkable cultural and elite buildings, but how this thinking can play a role throughout the architecture, engineering, and construction industry. In my work and in my research at MIT, we're promoting a way to do this through digital design, through using computation to allow us to flexibly and creatively and systematically explore large design spaces of possible solutions so that we can find potentially optimal solutions, but also balance performance with other really important goals driven by human expertise and ingenuity and creativity. We find when we model buildings at the full scale, we can start to find dramatic carbon reductions that, again, are not possible through material substitution alone. Things that all of you know, reducing the spans of columns, looking at different structural systems that articulate material more intelligently, like adding ribs or shaping elements. Combining all of these can reduce carbon dramatically. And when we start to study these across many different building systems, as we've done here with a large-scale synthetic data set, again, we see that changing material by itself, so here each one of these bar graphs represents a different building, different span, different material system, and different sort of embodied carbon incentives like the Buy Clean Act, which was recently passed in the United States. We see that material substitution has a modest savings in terms of overall carbon intensity, but larger scale decisions like reducing the span of the columns, introducing smarter shaping of structural elements, reusing components, using all of these ideas together produces not only one solution, but many different high quality ways to reduce carbon that promotes innovation and creativity and allows us to find solutions within our local context. So I'm really inspired by seeing all of you doing this today. And I think this is absolutely the mentality that we need to take forward. How can computation help us do this further? I'll give a few examples of emerging tools and approaches that we're developing in our research and also some recent prototypes and projects. One way that we're thinking about how we can expand design space exploration is using generative AI to learn new design spaces. So really complex spaces of buildings that have hundreds or thousands of variables are practically impossible for us to use existing optimization tools to explore. The problem space is just too big. But modern generative AI tools like this can learn a new latent space of high performance possibilities that start to make sense of really large scale data to help us discover new ideas. We can also do things like use surrogate modeling to rapidly anticipate structural performance in early stage design. Here, our surrogate model is not only producing a single number, but it's representing an entire field. We're instantaneously predicting the result of a topology optimization that's running over the surface of this shell. So if I change the shape of the geometry, I can instantaneously see how a material should be optimally distributed, which changes these engineering techniques from things that can only be done once or twice to things that can happen in rapid, iterative, creative workflows that are collaboratively pursued by architects and engineers together. We can also start looking at how new AI tools can collaborate or be compatible with engineering techniques like topology optimization. This is kind of a funny example, but here we're using a text prompt for a human skeleton combined with a topology optimization technique to find a sort of new form of skeleton for a building. And this is not necessarily immediately buildable. There's some issues that come out in the results, but to us, it's this really interesting set of experiments that start to show how we can combine human intent, creativity, design impulses with performance-driven design to arrive at new types of solutions that start to connect poetic influences with rational form making. It's interesting to look at some of these examples that start to look really naturalistic, and it starts to remind us that actually the natural world also offers a lot of opportunities for us directly to reduce carbon in structures. And indeed, people working with wood and trees have been doing this for centuries. For example, in historic shipbuilding, trees were used in a minimally processed way to find high performance structural pieces that meet the geometry of the trees where they are to find the shapes of the boats. We've been exploring a similar idea in our research where we're saving trees from being chipped and having all of their carbon released and identifying their joints as potential structural connections. We can use digital workflows that allow us to digitize this inventory of tree forks as structural connections and find design possibilities that make the best use of these materials. So how should I change the design of this grid shell to better use the tree forks that I have available? And how can automation like robotic bark removal make this scalable so that even though each branch is unique, the toolpath automation happens in an automatic way, and so it's highly repetitive. We can also do this without robots. We can use emerging tools like augmented reality to use really traditional carpentry joinery techniques like scarf joints, but cut all the pieces informed with our digital tools. We're starting to think about how these can also inform larger scale building structures like the column grid inside of a building. This is a recent project that we showed at the Venice Biennale where we're working with Whole Trees, an industrial partner who do large scale minimally processed structural trees in buildings. We're starting to think about how new forms of column grids could emerge, thinking in this kind of circular and digitally empowered way. This circularity idea is more general than just trees. We've had a kind of very general approach where we understand supply and demand in structural form making, where we can design structures to respond to an inventory of many different types of parts, of linear elements, of rubble, of offcuts. Here we're looking at how we should change a truss or how we could design a truss in response to an inventory with optimal matching that happens in real time thanks to really fast underlying algorithms. We're applying these techniques to ideas like how can we use scraps of dimensional lumber to produce high performance structural components like dowel laminated timber floor slabs, which can automatically make use of a scanned inventory of scrap and use dowels to successfully load transfer if these scraps are organized in the right way to produce new shapes for buildings. This is an interior of a prefabricated housing system that we recently designed with a colleague and architect, looking at how scrap wood could support low-cost prefabricated housing that's also beautiful. And finally, I also want to talk about concrete, as this came up quite a lot today. Concrete's a really important material in our history and likely also in our future, but we need to start using it in a dramatically different way. Of course, we need to use alternatives to cement, but we also just need to use a lot less of it. The great news about concrete, as I suggested earlier, it's very possible to do this. Concrete is one of the easiest materials for us to sculpt and remove unnecessary material because it's cast, and it benefits tremendously from that process because it is so heavy. And so our process that we've developed uses shape optimization to find optimal configurations for ribbed structural systems that follow building codes that are based on today's knowledge, that use today's materials, but that can reduce carbon by 70 to 80%. We're working on disseminating this in high impact applications like affordable housing in the global south. Here's a prototype that we built in Mexico with partners. My students who worked on this are commercializing this technology, this shape optimization technology, with a new startup called Forma. They also use techniques like additive manufacturing of very low cost formwork to de-risk scaling up these new precast concrete techniques. And they're demonstrating the potential of reducing the concrete and the weight not only saves a lot in the floor slabs, but also has all of these downstream benefits, reducing carbon in beams and columns and foundations, all of which can become lighter. The final project I'll show very briefly connects a lot of these ideas together. into a product called Pixel Frame, which is a precast modular circular concrete system that uses substantially less upfront carbon through intelligent shaping and is also fully circular and reconfigurable thanks to its modular design and a demountable post-tensioning system. The idea is there's one unit, the pixel, that's repeated in many different ways. Pixels can come in different strengths so that we're only allocating carbon and high cement content where it's necessary. And the pixels assemble to become beams, columns, and frames for buildings. The pixels themselves can be reused many times. The metal components can be recycled. We use an optimization technique to automatically design these systems with a fixed inventory so that an architect or a structural engineer designs the massing and the rest happens in an automated way so that we can start to circulate pixels across many different frame types, many different types of buildings, from industrial warehouses to high-end cultural spaces to adaptive reuse commercial buildings and offices. This team is actively looking for collaborators, so if anyone's interested, please do reach out. To conclude, the climate emergency is a huge wake-up call for our industry, but it's also an opportunity for us to transform the way we work in a positive way. Thank you very much.
Wow, Caitlin, that was awesome. Thank you so much. I'd like to invite back Paula, Takuma, Barbara, to put on your and Menno as well, sorry, to put on your cameras again, and we're gonna have got some questions from the audience. But I just want to start out, Caitlin, just while it's fresh in my mind. Love the tree nodes as connections, and it's a very regenerative principle, isn't it? You know, utilizing materials we already have. What do you see a future for inventory constrained design? You know, given that we are, you know, as men have said, we've got these buildings, we're trying to urban mine. How can digital play into having a kit of parts and utilizing that efficiently?
Yeah, absolutely. And a lot of people, as Menno said, are actively doing this. And so I think the question is, how do we move this from the margins of exceptional work like Menno's to standard practice? And I do think digital platforms can play a really key role here. One of the key questions is, how do we represent these inventories digitally? There's a lot of interesting work in computer graphics that can start to answer those questions. Another key question is, how do we understand the mechanical behavior and properties and damage of salvaged parts? There are also a lot of people doing really excellent work in this area. And there's a lot of existing knowledge from historic preservation work that we can apply to this question. So I think it's a question of connecting a lot of existing knowledge and networking and convincing people that this is safe. But I absolutely believe this is has a strong future.
Yeah. And Menno, any other comments to that?
Yeah, we find very interesting what Caitlin said. We are currently participating in a program where we try to make an inventory of existing buildings from Google Street View images. Ooh. And making an inventory of the materials and the potential reuse, the reuse potential of buildings in large sums. So that makes it easier to predict what kind of buildings, what kind of materials will become available, because we see a lot of the problems are not so much technically, but are very much logistically. So the demand for a certain material almost never at this point comes at the same time as the supply. So so a lot of people say that we have to make big hubs with materials and store all the materials there, but that's also the perfect way to make it economically not feasible. So what we are focusing on right now is replacing or entire buildings as a system of materials. And there we see that it's economically viable, interesting for all parties, for the previous owner, but also for the new owner, and also for us as a commercial company. But those AI techniques of trying to forecast what materials will come available and what the quality is, that's something that we're also working on. I think it's very promising for the future.
I think that's really important. It's about having the centralized data system, because what we're seeing in the UK is we have these lovely bespoke projects in London that are, you know, utilizing materials from other projects, or going out and finding them in the market, but it's a very limited pool of knowledge and projects that are getting that data, meaning that it's now just like it's boutique London projects that have that as their kind of USP. But ultimately, to get that wider change, we need the national or international, maybe not international, but national level data. So Caitlin, are you seeing that, and Menno, are you seeing that, in your communities, rather than it being local knowledge? Like, is there a push for a national ownership?
I mean, personally, I think the scale is a good thing to debate. I don't personally think we need a global supply chain of circular materials. I think we can work in a regional way, depending on the resources that are available. Of course, there may be occasionally longer supply chains, but working regionally has a lot of benefits in addition to decarbonizing. And there's a reason we've worked that way for a long time. So I think we should start with sort of replicable, locally networked models and learn from each other. We can still globally connect and learn from each other, but we don't need to physically send our materials around the world. I think we've learned what the downsides of that are. And that also then means that the available materials will start to be more specific, which also has a lot of benefits from a climate perspective.
I totally agree. It's not very useful to ship all those materials all around the world. So that's make local network systems. Yeah.
Yeah. Okay. Perfect. Thank you very much, both. We've got. I mean, I have so many questions. We've got loads of questions, but like Barbara, your tires went down a tree in the chat. I was loving them. You also mentioned you've got lots of natural materials details that people can, copy and use. First, where can our audience find those? And second, if we did want to start using these natural materials in mainstream construction, are there enough contractors who know how to use them?
Yeah, well, two very good questions. First of all, the details, I mean, all my life I've tried to share knowledge widely and not hold on to it. And there are details available on the Strawworks website under the technical resources section. People can also contact me direct. I'm very happy to send PDFs to wherever they're going to be useful. What was your last question? I know you asked something else.
Okay. Do we have contractors that have that?
Yes. No. I think the answer is simply no, but we do have a lot of people who do know how to do it, and we have a training system. So it's possible through the School of Natural Building. We've been teaching these techniques for 25 years or more, and it's would be quite easy to scale those up, and we offer bespoke training courses to anybody that wants them. So any contracting company can come to us and we'll teach them how to do it, and we'll teach you on a real building so that what you're learning is actually going towards the building that you're doing. It doesn't take long. What you need is somebody who's in charge of quality control.
Yeah, fabulous. And what of the natural building materials that, there's lots to explore. What are you seeing as a trend right now? Is it the straw?
I'd say it's the straw, because we've now got a modular system available with the straw, and that is a real game changer for mass housing. So those people who know me know that I've tried to get construction to work with the small field bales for a very long time without any major success. Self-builders love them, but contractors don't. But with the modular system, you don't have to relate to the straw at all. It's just like screwing big boxes together. And if you can't do that, then you shouldn't be on a building site, to be honest. So it's very easy. It's so easy that self-builders can do it.
Yeah.
So the Eco Cocoon straw panels are a real game changer, and they'll be manufactured in this country as soon as the demand increases a little bit more.
Yeah, love that. Thank you, Barbara. And I've got a kind of shared question for Paula and Takuma. So Takuma, you presented some, clear evidence that we have to use less stuff, very thoughtful, detailed Sankey diagrams. And we know recently the iStructE also published a paper on scrap steel, and identified this kind of headline being that we only have a third of scrap to meet our global steel demand, just as you said. So with that in mind, I kind of a question for you both and to Paula, knowing that, you know, we're talking about planet and ethics here, knowing that we are using too much stuff, at what point are we going to have this conversation to say that extracting more steel, using more materials on our projects isn't ethical for new construction, given that we've seen from Menno and we've seen from Caitlin that we've got an abundance of materials. It's a really difficult conversation to have, you know, everyone kind of grits their teeth. But Paula, maybe can you share some suggestions of how someone could kind of go about having this conversation?
I mean, generally, we've just got to accept that we've got to make progress over perfection, right? That we can't solve all of the problems. You know, there's theoretically, it would be lovely if we look down all the different sort of suppliers that we've got and make sure everything's absolutely ethically resourced and sourced to within an nth degree. But we know that that's not possible practically. You know, this is the reason why in emissions we've got scopes 1, 2, and 3, and there's timelines for it. You know, there's a whole host of reasons. So for now, for today, what we should be doing is doing the best we can with what we've got and look at that balanced approach for everything. But what we should be bearing in mind is remember that this space and the climate space is the same, that at some point somebody is going to make a legal claim against someone and it's going to be in the courts and they're going to be culpable for it. So I think that's what people need to bear in mind. But like with everything else, if anyone can demonstrate that they've done the best with the decisions that they've made at that time, that's all anybody can ask of anyone, and make that balanced approach. But I think the real game changer will come when, you know, it could be a community group, an organisation, it could be a client that actually makes a claim to say, I was expecting my building to be green and you haven't provided that to me. So bear in mind, there's a real business case for this. It will be coming. It's not when. It's not if, it's when.
I think that's a really good point. And Takuma, like what we're seeing in the UK European market is that green steel investment is on a decline. There's a lot of pausing, DRI investments going down. You know, there's a big challenge on it. So I think there's a real interesting overlap here of clients wanting green steel, wants this green products, but it's actually not available because there's all these geopolitics. There's, you know, the capital investment required. You know, there's going to be a problem, isn't there here? You know, what do you think of that?
Yeah, definitely. I think like for me, in my experience, like discussing with this idea of like using less materials and also using green materials with construction companies or structural engineers or architects is quite easy. But talking about like materials company is a bit tricky because at the moment the benefits is directly linked to the volume of materials they sold they sell to the other companies. So I think this is sort of a big challenge where in Japan, for example, we have a lot of big materials industry and they want to operate existing facilities as long as possible because of the profit reasons. So without having a demand for these new materials, and there's less, I mean, there's no benefit for them to invest in new technologies, but they know the market will be coming in the next couple of years, but then there's lots of uncertainty, and there's lots of uncertainty also if we build DOI facilities, but if we don't have the access to green hydrogen, then there's it doesn't really make sense. So I think there's lots of like balancing between infrastructure development, facility development, also the demand from the construction companies, and then I think this is where the governments play an important role, I think.
Yeah, absolutely. And then I guess firing back, Paula, you know, to that point of we need to make progress. We need to ask sometimes uncomfortable conversations, but you know, progress is better than perfection. what skills do engineers need to make the right choice or to have the courage to ask these questions?
Well, they do need the moral courage without a shadow of a doubt. You know, it takes a certain type of person normally to put the head above the parapet. And, you know, so you need to pick your battles, I think, is the thing. And you pick your battles by deciding on what's going to have the biggest impact and what you're also in control of. And it's the same as doing any risk assessment, any assessment of anything that you're looking to do. And, you know, pick the thing that's going to have the biggest impact, and then get your facts straight. Remember who you're speaking to, remember who your audience is, and make your arguments for that change to the audience. So sometimes the conversation of saying it will save materials or CO2 or travel or whatever is actually the argument to be made. But sometimes the person that you're speaking to, that's not of interest to them. So is it it will be more resilient in the future. It's going to have less chance of having a claim against it. It's going to be cheaper now. It's going to be cheaper in the long run from a cost perspective. So get your facts straight. Find your what's going to have the biggest impact. Think of your stakeholders and make the right argument to achieve what you're trying to achieve to have the biggest impact. And engineers, technicians, this is what you do. You balance the risks, you balance the thoughts, you balance the decisions, you make them all the time. This is just thinking about it in a slightly not different way, but in addition, another aspect to think of.
Yeah, absolutely. Okay, that's very useful pointers. Thank you, Paula. I've got a question for Barbara. We're going to go into some of the audience questions now. What would an increased demand in the UK for eco-cocoon or similar systems enough for it to take hold? Maybe others can reflect on similar barriers preventing us from reaching tipping points for these technologies or materials and approaches.
I think we've got to get to be something like building 30 to 50 houses a year out of eco-cocoon. So it's not a huge amount, but it has to be economically viable for the company that's developed the way of building to bring their computerized and digitalized factory to the UK.
I'm just laughing at myself there. It's eco-cocoon. There's too many cocos in there.
Yeah, I usually say eco-cocoon, which is what it actually means in other European countries, but the spelling is different for us.
Yeah, okay, so really not much then you need to scale that. That's
really, what we need is one big developer to say, right, I'm going to do this.
I need to talk to you offline.
I'm up for it.
Yeah, I mean, if anyone on this call is thinking we've got opportunities, then yeah, get in touch with Barbara because there's really not much there. And we have a 1.5 million homes opportunity right now on our hands. So yeah, I think there's lots of work being done across industry to capitalize on this opportunity for bio-based materials in new homes. We have to take it.
And remember that the straw panels are structural panels as well. You don't need another framework with it.
Yeah.
And even the eco-cocoon engineers do the work on that. So you just do the rest of it.
Yeah. Perfect. Okay, that's great. And Caitlin, you know, over in the US, what barriers are you facing for scaling up these technologies? You know, from a research point of view, it's really exciting. What's happening on the ground?
Well, it's a difficult time in the United States right now, as you may have guessed. But personally, I'm extremely inspired being here at this event. I just want to say that I think you are all doing a fantastic job. I think a dominant narrative I hear more often, especially on the policy side in the US, is what Takuma just told us will never work, that the only way to solve this problem is at the supply side, and we just need to decarbonize the industrial sector, which will take billions of dollars and decades that we don't have. And this alternative idea that instead we're going to do this grassroots thing where we're going to work with all of the architects and all the structural engineers and teach them all how to do things in a new way. I think this is an incredible example in the UK that you're all carrying out, because there is some resistance to that in the United States, that is a very, very challenging thing to scale because of the distributed nature of that project. And yet it doesn't cost very much, and it has a lot of other co-benefits in terms of transforming our industry. So I'm totally aligned with the approach that you're taking, and I'm very inspired by it. I do think another, as I quickly alluded to in my talk, I think the mechanism that we're seeing potential for in the United States is entrepreneurship. There are a lot of recent failures in this space of people trying to start ventures, bringing new ideas, bringing new ways of building into the market. But I think we will find the right ways to do that. And there are a lot of smart people who are working on that. So I think, especially in the building product space, and trying to do a thoughtful and appropriate amount of vertical integration that's not complete, but that has some advantages in terms of scaling or some kind of cooperation across networked groups. So I think that's the approach that I'm seeing having the potential to take hold in the near future.
Thank you for that. Any other contributions on that question? What are you seeing for scaling up in Japan, perhaps, in Asia, Takuma?
I think in general, like, I'm not really sure about the Asian wise, but in Japan, definitely we have like techno optimism about just like waiting to see the new technologies come up in the future. And so what we need to do now is just invest in new technologies and just saying, hoping new technologies will come up in the next 25 years. But then I think we often miss the concept of carbon budget because it's a cumulative issue, right? So if we emit the carbon into the atmosphere, then every ton contributes to the climate change. So we need to reduce now. And I think that's currently missing in the policy sort of making conversation in Japan. So I think that's one of the topic that I want to highlight more in the government conversations.
Yeah, absolutely. I think you're absolutely right. There's a strong focus on moving towards these lower carbon materials. So much so in the UK, this consultation has come out about how should we measure low carbon materials, what's good, what's bad. But there's been, less focus on, reducing the need for materials, full stop. And yeah, it's really disappointing that, that's been the focus rather than using less stuff. As we are on this abundance of, fantastic materials at our disposal, as we've demonstrated today. We've got some more questions for you, Barbara. Some timely ones about extreme weather and floods that we've seen in Texas this week. How can we ensure that natural and bio-based construction materials are robust enough for long-term performance? And what strategies should we adopt to balance environmental benefits with durability in exposed or vulnerable settings?
Okay, so there's a big misconception that natural materials are not durable or don't withstand the weather, which I thought I must have alleviated that, because we've got some that are thousands and thousands of years old that have been through very serious weather systems. It's a real myth that they're not weather resistant and that they can't deal with changing climate conditions. Some types of foundation, like the car tires, a pillar type of foundation is really great for flood conditions because the flood just goes underneath it. And that is a feature of pillar type foundations, and we can choose to make pillar type foundations out of natural materials or recycled materials. So the Eco Cocoon panels, they are clad with lime render or with timber cladding or a mixture of both. Lime render has been around for thousands and thousands of years. We have still got existing buildings, thousands of them, millions of them, that are clad in lime render. It is one of the best materials for dealing with moisture, far, far better than concrete render. And so all you have to do is find out about these materials. The reason why we're not using them is to do with economics. That's all. It's not to do with their quality or their longevity or their durability, because those are proven again and again and again just by opening your eyes and looking around you.
Yeah, I can completely agree that it's such a shame that we have lost like the craft and art of of lime. I tried to advocate for its use on a retrofit project. We were putting quite a lot of new masonry, and it just whacked the program because it takes longer to cure and they can't go as fast. And it's just such an unfortunate and, you know, single visioned view of.
I think you've got to think outside the box. So I'm a founder member of a learning centre in Todmorden, which is a massive vocational training centre built of brick in the 1950s. And we are retrofitting that with natural materials, external insulation, and we're able to do it within our budget. It's just a matter of vision and determination. It's not that it can't be done and it can't be done within budget. It can. There's just this mindset. We don't want to do it, and so we're going to put all these obstacles in the way. That's what it is. It's mindset. It's not about whether or not it can be paid for.
I think you're right. I think the reality is it's very hard when you're the only one that's got that mindset and everyone else in the design team doesn't.
Tell me about it.
Yeah, I think when you have that real collective and shared mission and purpose, that's when you hear about these amazing projects, isn't it? But it's really hard, and you're almost hitting yourself against the brick wall that you're trying to lime when you have these situations. But yeah, it's really good reflection that we have to advocate harder. And there's amazing people within this industry that do advocate for natural materials, but it's generally not so much within the kind of typical structural engineers. So we all have a role and responsibility to be advocating for traditional materials. You know, concrete isn't a traditional material. Let's call traditional materials our bio-based ones. Thank you for that. Right, I have a very difficult question for you, Paula. I wasn't sure whether to say it, but I think it's really important to, because in ethics is all about confronting these difficult questions, right? And one that I'm not sure if our audience will be fully aware of. We are seeing a huge switch to low carbon energy sources such as solar PV and EVs. PVs particularly are sourced from a province in China which has known to have child labor issues and exploitation of marginalized groups, which is really difficult. And that I can't remember the number exactly, but it's a very, very high proportion of PVs are made in that region that we utilize for decarbonisation in the global north. And these challenges are at systems level. So Catherine's asking, what are the best methods you've seen to mitigate these risks, and what advice can you give on these types of challenges?
Yeah, I mean, it's similar to the conversation we had earlier, Brogan, to be honest. It's like there is, you can say, I'm not going to do that because I don't believe in the ethics all the way down the supply chain, right? And I get that, and that's a solid ethical stance without a shadow of a doubt. However, there's the argument that somebody else is going to build it and do it. And then there's the other argument, if you don't do something that's actually for the, a carbon reduction for the planet, then you've got bigger problems. So none of it is an easy answer. I mean, there's certain things that we do that we know are just plain wrong and we shouldn't be doing them. But everything else is the shades of grey, and it's a matter of, how right and how wrong. So there isn't one answer to any given question, I would say. And that's something that everybody needs to understand, that every single problem is, and in terms of ethics, is very nuanced. And also you can't control everything. Somebody some point's going to actually say, sorry, like you and your lime, sorry, it just isn't happening. Yes, it might be the best ethical and sustainable solution, but there's 101 reasons why you can't do it. But if you give up, Brogan, then the next one, you'll never say, right? And you might only get one project through in 5, but one project in 5 is better than none at all. So I think you've got to look at everything in its own merit. But the key, I think, and people have mentioned it, is the demand we need to get things to be manufactured to scale up. And entrepreneurs are probably going to be the ones that fill these gaps. But what's absolutely clear from a structural engineer and technician point of view is, unless we keep asking for it and we keep exploring the options, and when we find one, share it, then nothing's going to change. So I would say that you need to look at your project individually, accept that you can't change everything on every project, but look to the future and think, right, well, what made me feel a bit uncomfortable about this one? If I can't solve it today, if I can't find an alternative supplier today, what can I actually do to look at tomorrow's project? And again, it's back to this progress over perfection, because there isn't such a thing as a perfect choice ever.
Very good answer. And I think, you know, I'm currently in conversation with a child labour expert around construction materials, because there just isn't enough conversation around it, and it's actually shocking. The bricks and stone that we use is imported from Pakistan and India using child labour, and we're trying to understand, like, what's an actionable way that we can approach this. And you would think to say, look, we're not going to use that supply chain. But then you have to think of also the unintended consequences of doing that. And actually that can really deepen the livelihoods of those people, because there's bonded labor and all these other things that they use for eating, you know, that puts clothes on their backs. And it's really, really complicated nuance. So I think that's really good guidance, is actually you can be really quick to come to a conclusion that you might do this or that, but actually exploring the grey is the best action that we can take, and just having the uncomfortable conversation, like, you know, bringing that to the table is the best, right?
Indeed, keep having them open conversations. Have the moral courage to have the discussion, but let's not let a knockback sort of stop you being hopeful for a better future.
Yeah, absolutely. And I guess as well, if we think about like all these global materials that we've been talking about today, then right down to the local ones that are, you know, that are in our communities, that are urban mined, and the natural materials that we can get from local sources, the ethics question, once you come down to that local level, becomes a lot easier. You know, get rid of a lot of these challenges. The more local and the more reused materials that we can source, we are designing out ethical challenges that we might face in the future. We're talking about, you know, you can get taken to court for things in the future, you know, if it's not ethical, and we don't know what that future is going to look like, but there's a strong opportunity there for using locally sourced bio-based materials to support that. But to end on a positive note, because I don't want to be talking about you know, finishing off on the kind of sour one, I want to ask all our panelists, you know, we've had about 350 people at peak on today, so you've spoken to a lot of people today, and there's been a lot of action, a lot of inspiration. But if you were to finish on one word of action and motivation and inspiration for our audience today, what could that word be? And Paula, since you're on my screen already,
hope. I'm going to go with hope. We've got to keep hope.
Yeah, I love that. Thank you. Barbara?
Bravery.
Bravery. Love it. Love it. Thank you. Takuma?
I'd say speed.
Speed. Yes. You're that quick. Thank you. Menno?
Difficult to say one word. I would say, yeah, we talk about the future is circular, but I would also want to stress that the past was also circular, only the present is not circular. So all those together is like hope, and try to change and feed the transition with the stories that I heard today from all the speakers. And every transition starts with those stories and gets people enthusiastic. And that's what we should keep on doing. More than one word, sorry.
That was a lot of words. There's always one that can't keep to the rule. Thank you, Menno. And Caitlin, finally.
Yeah, I would say beauty, both of the natural world and the one we hope to construct in the future.
I love that. Love that. Thank you so much. Oh, well, thank you very, very much, panelists. Thank you for your really inspiring talks. Like, that has left us all feeling really hopeful, you know, really beautiful of our future, that we all have a role and opportunity to act in. So thank you very much.